So I'm going to go over this real quick first before we get into the visual fun stuff. This is the UE4 documentation. Super, super verbose if you can't tell down here. You know, each one of these expands into more and more menus of stuff. And then it's even more stuff inside of that stuff, right? So it's really, really great for getting started. I did find this really nice thing. So this is new, and I really appreciate it because they know, I think Epic is very aware that people are going to start picking up more people. So on the right-hand side, they've added this related courses, your first hour with Unreal. And this is literally a course, start course, and it's going to teach you probably all the shit that I'm probably going to teach you, maybe even more. So this is a great resource to learning Unreal. And then if you ever want to just like filter for something, like let's say like forward renderer, I think it's renderer. Yeah, forward shading. Here we go. And now this is talking all about the forward renderer for VR and Robo Recall. So yeah, and then the technical breakdown of things and the way that they describe like what settings are changing things and how that looks and is represented in your game. So, and this game was fantastic for the quality and like the tech that they used and had, and they made it work and how it runs. Still probably one of the best VR experiences I've had. If you haven't done this yet, you should check it out, Robo Recall. And that was with the Oculus. Even before the first Quest came out. So yeah, very verbose documentation. Use it, love it, because you're going to have to. Let's see, Epic Games Launcher. Oh yeah, we are going to launch. So this is the Epic Games Launcher. If you played Fortnite, then you'll no doubt are used to seeing this. What you want to do is, where did you go? Oh, it closes when you launch the engine. So you have your store, which is like what games are on the Epic Games Store. We have the library, which is the games in your library, and then you have Unreal. You want to go to Unreal, and then you have your unique tabs there. You have the Learn, which I wonder what the hell that does. Marketplace. This is what I was telling you guys about, and this is a great way. Okay, first of all, every month they release, even if you don't make games, every month they release free content on the marketplace. So you could literally just get free shit and just save it. It's just a bunch of game design assets and like textures and alphas and like cool shit like material effects, visual, like just every month like you went and just accrue that and then make a game out of that shit. Like that's how much you don't have to try. But it's amazing that there are people on here that are really putting a lot of effort and work into making these things come to life. You know, some people have like really high quality characters that they'll put up here. Like this is pretty good. And it does get put through a curation process. It needs to live up to a certain standard, but it does sometimes feel like that standard is flexible. But yeah, again, great place to find some assets and get like, at least like if you don't know how to make a character, you can go get one for $4 and it's like the perfect biped that has a bunch of functionality. So you can focus on making what you want to make. All right, so what we want to do is once you get into the Epic Launcher and go to Library, if you haven't already, to install an engine version, you press the plus sign and then you have a drop down of all the ones. Typically, you want them. What I usually do is I would have 426, 427, and then Unreal Engine 5. 427 is stable, but it's the most untested stable version, if that makes sense, because it's the latest, right? It has more features than 426, but it's not going to be as stable as 426, most likely. Unreal 5, obviously you can't work with that yet. So keep that in mind. And a lot of content and plugins that are made, they're usually the version prior to the latest. You'll find the most support. So that's just a little tidbit of information. So we're going to launch. and it's going to prompt us. Whoops, I already did that. Let me close this. There we go, same window. Okay, so launch the engine, and now we get to choose like what we want to make. We're going to make games, but you can do film and television, which connects to like NVIDIA displays, architecture, engineering for like ArcViz projects and stuff. And now we have templates. You can see we have the VR template, which is kind of new and updated. Definitely look at that. You can do a blank, which is just literally no code, no nothing. It's just an empty environment and engine assets. And you can do first-person shooter, flying, puzzle. You got rolling, third person. I usually make a third person just because I like to see the character when I'm doing stuff. And it gives you a full animated character as well. Top-down, twin stick, AR. This is the handheld AR, side-scroller, vehicle, and then vehicle advanced. Now, these are all templates. You can, if you have someone who's smart enough, engine programmer, you can make your own game template that has its own stuff, and you can just create projects based off that. But what we're going to do is let's do a third person just because I'm most used to that. And then you get to choose mobile or tablet, like the quality, the target hardware, and this comes with knowing your audience and knowing what platforms you're going to ship on. We'll keep starter content in there. Ray tracing. Real-time ray tracing is a new technology that's being pushed a lot and is great, but it's also still very costly, so just be careful with that. All the NVIDIA cards that start with RTX, those are ray trace capable, hence the R. And they're great, and they can do regular stuff too, but they're just optimized to run ray tracing. If you decide to do a ray traced game, just know that that technology isn't, you can't just turn it on every platform. Like on Nintendo Switch, you can't just be like, enable ray tracing. Like, it's not going to do it. You have to kind of integrate and implement your own solution there, which that's where those engine programmers and engineers come into play, graphics programmers, really. So yeah, we'll leave that disabled, maximum quality, and this is a blueprint project because I don't code, but you can do C++. I can code, but I don't do it because I suck at it and don't like it. No, I do actually enjoy it. I'm just not very good at it. We'll do test BP project. Down here, this tells you the location of it. The default, it'll always create, if you don't have one yet, an Unreal Projects folder in your Documents directory, and then in there you name your project. So we're going to go here. And the first couple things it's going to do is it'll initialize, and then we will hit compiling shaders. And shader compiling is something that if you work with Unreal, just get used to it. Shaders, if you don't know what they are, it's a material. It's essentially a material. A shader goes on top of an actor, a mesh or static mesh, skeletal mesh, static mesh. They can also do other stuff. Shaders can do UI stuff as well, more advanced shaders. So this is Unreal Engine 4. What I like to do when I'm working on single screens, which isn't often, but I like my screen space. So I will grab any of these this content browser tab, and any of these can be, see this little golden, you press it and it shows the tab related to it. Come here. There we go. And you can actually right click and then do hide tab again if you want. But what I like to do is I go content browser can float. Now I have already a lot more view space. And then I grab place actors because I'm never placing and looking at details at this at the same time. It's a one-to-one, so I just dock it over here. And now if I ever need the content browser, I think it's Control B. Yeah, just press Control B, then you minimize it again. Or you can put this on like a different screen, like elsewhere, extend it. So yeah, content browser, like I said, this is important guy. I'm trying to think of what we want to do here, because there's a bunch of things I was thinking about us trying to do. But I'm wondering if y'all even know much about materials. It's something visual to look at, and it's also kind of fun. So we'll do that. We'll create a new material, and then we'll put it on a cube, and we'll make the cube like bounce only in the material. And what we'll do is we'll have it bounce when the player overlaps a volume. It'll play the thing to bounce. That's what we'll do. All right, cool. So first things I like to do is right now you see the shadow hanging around, and then as soon as I moved it, it was like lighting needs to be rebuilt. That's because I'm using static lighting, baked lighting somewhere, and I invalidated it by moving this actor, and that's why this shadow's still around. I don't want to deal with any of that because I am not doing a VR game where static lighting is everywhere. Write that down. Static lighting is going to be your best friend. So what I do is I select in the world outliner, I select all the lights in my scene. So I can also do light, just type light and it'll filter to light, and I set everything to movable, which means it's fully dynamic. No thank you for the baked lighting. Sweet. This little fun guy up here, this is how you start tutorials in the editor. If you're still overwhelmed and you're like, I just need something to guide me through this, you can select those, and it'll literally step you through, like, here's the editor, here's how you move. So this is a great way to, like, if you're not even comfortable being in the software, select the little available tutorials. I hate them because I know everything about Unreal. Not really. I don't know everything. I know a lot, but I disable them. Disable all tutorial alerts. You know what's funny? I was the one who wrote the feature request for this to be put in because I was like, I am so tired of these green circles flashing on every new window I open with the stupid little hat. And I entered that bug, and like a bunch of the engineers and developers, I thought they were going to be mad, and they were like, haha, like, we definitely want this. And I was like, yes, they feel the same way I do. Yeah, that exactly. All right, so what I'm going to do is do a little pie, which is play in editor. So as soon as I press play, it'll inherit this character, and I can run around. So now I'm like, woohoo. Running around doing stuff. Little Mario, bing, bing, bing. Really easy. What we're gonna do is we're gonna make a material. So if I was being organizationally savvy and being a good person, which I am, I would make a new folder, call it materials, and in this folder, I would right click and make a new material. And the naming convention would be M for material, underscore, let's do this, pulsing cube. Cool. Wonderful. All right. Materials. I remember when I first saw this, I was like, oh my God, this is so overwhelming. But it's really not. It's not as bad as you think. So when you're making materials, you have this little preview editor here, and it has controls, viewport controls. If you hold the L key, and this one you won't remember, you'll just have to practice. Middle mouse, you can rotate the light source direction, which is pretty helpful. But you can also, the more helpful thing is going to window, and whenever I find preview scene settings, so this is my preview scene. And then you have the lighting information here. So I can increase the directional light intensity and the skylight intensity at 2 or 1. What I don't want, which bothers me, is there's this thing called auto exposure, or like eye adaptation. Basically, a lot of games use it, and it's great, especially combined with Bloom, where you're like walking in a dark tunnel and you're in a cave and there's sunlight out and you see that real bright bloom, and as you transition your light, and it's like what your eyes naturally do, they adjust to the brightness outside. It's a cool effect, it's great, but I don't want it when I'm trying to fucking look at a material. So I can just disable post-processing, or I can go to lens, and there's this thing called exposure, and on exposure compensation, just set it to 0. And you saw how it like kind of did this. Like if I set it to like 2, see how it's changing? 1, 0. I want 0. And I want the light source kind of be directly down or up, kind of down and back. All right. Cool. Now that we have that set up, which you don't really need to fuck with it as hard as I did, pardon my language. But how do I explain this? A material can exist in a bunch of different ways and can appear and have different properties. For example, we call that the blend mode of a material, right? So right now, an opaque material is this. This is all opaque. You can't see through it. It's sort of a hard surface material. Masked can also be hard surface, but it can have an opacity to it. So it's like if you were making a, let's say you were making a widget and it was a circle and your texture was a white circle and you needed it to be masked. If you mask it, it'll make sure that it only shows the white circle, and the black that's the background will be set to translucent. And you plug that into your opacity mask. For example, let's actually start with opaque. I'm getting ahead of myself. Let's go back to opaque. Opaque, physically based rendering, PBR. Do you guys know what that is? Cool, we got one. That's okay. So PBR is a term given to the way in which Unreal handles rendering physically accurate materials. You can define a material by using values, like for example, so base color, we have these inputs. These are what's driving your material to do the thing. So base color, if I press the 3 key, which stands for 3 vector, and left click, it'll create an empty color, which is by default black. Let's give it a nice little red here and plug that into base color. Ta-da! My sphere is now red, right? Amazing. What you can do though is now, let's say in Blueprint, in game code, I want to modify this color at runtime. I can right click this thing and convert it to a parameter. A parameter means this thing is now ready to be instanced and modified at runtime, meaning there's a value here that we want to change. That's all that means. So parameter, I'm going to call this base color. That's just the name of the parameter. Awesome. Now we have the metallic value. If you're going to do PBR, what I was talking about earlier, is typically reserved for games that are shooting for realism, like realistic. So they use properties like metal properties, and you can use like 0.015 for roughness and metallic, and that's like the actual values for like gold or aluminum or copper, and those drive the reaction to light. So that's how you get physically based rendering. You put in, like, it's like you have this list of metals, and all these metals have very specific ways that they respond to light. How do you get those values? Well, those values are set here, and then no matter what type of light that you're hitting it with, it's responding accurately based on the type. And that's sort of what PBR is about. So in metallic, let's make this thing non-metallic. So we're dealing with values from 0 to 1 in metallic. It's either 1, yes, it's a metal, which you'll see it looks now, it's got this like metallurgy look to it, or it's 0. Nothing is really, there's a term for it. It's like in between metals. And there are objects like that, but not often. Specularity is obviously, see this shimmer, this little sheen up here? If I set specularity to 0, that goes away. And now it's this very flat, just red flatness. And it has some shading, but that's only because it's an opaque. See this little shadow that's breaking here? If this was an unlit material, which I'll show you right now, unlit, that even goes away. So now if I plug this into the emissive, now it's just red. It's a red dot, right? So this starts to show you, and you can start to understand how complex and how you can start to overlap settings and it get confusing. This is what I was talking about. Start simple and just make sure you understand whatever you're looking at. Because as soon as you have a good baseline understanding, you can iterate on your knowledge. So I don't want an ugly thing. We're going to do 1. Same with specularity. You can drive it past 1, but it doesn't do much unless you're doing some really artsy stuff and crazy stuff and you're managing specular workflows. Roughness, this is going to make it very shiny. So a 0 roughness means it's a little weird that it's called roughness now that I think about it. Because if something was 0 rough, it would be super smooth. Yeah, I guess that's right. Yeah. So now this thing's super smooth and glossy, right? If I set it to 1, there's literally no, it's kind of almost fuzzy looking, right? And the default is 0.5, I think it's 0.5. Yeah, so you get this like kind of nice average. I like 0.15 for what we're doing right now. It's got a little bit of something to it. Your normals, this one's fun. Who knows what a normal is? Oh yeah. So the normal of this surface is this, right? The normal of this edge is that, right? And normals in a material can be used. You can set a normal, which is a 3 vector, to be anything, or you can set it to be tangent or world normal. So tangent normal is based on the shape of the object, or local normal, and that is inherited by default when there's nothing there. It just goes, hey, like this is the normals of this object, this sphere. But I can put in a world normal by doing something like this. And you'll notice a normal is blue. All normal maps are blue, right? Because it's what it's doing is it's telling you based on the angle that point or pixel is located, it's always going to point out as a normal, so it needs a blue 1 value. But then the ranges of red and green, so if you've looked at a normal map has red and green, those are how much it's pushing in the X and Y, right? So that's how you're getting those values. So normal maps will always be blue. But so this is a world flat normal, and this is going to make it look just the same because that's what it's using. It's using this normal value anyway. But that's just a little bit of information there. Ambient occlusion, that one's kind of easy. You just kind of define how deep the soft shadows, when you have a cube that gets into a shadowed area and then it touches a wall, it's like how much do you want darkness there? You can control that in a material because this also controls the lighting. This is sort of controlling the light reaction. So now let's do a little something extra here. This is my favorite. There are 2 favorite nodes that I have in a material. The lerp node and the Fresnel. So if we were going to preview this Fresnel, like what is a Fresnel? This is a Fresnel. It is a soft fall off defining basically 2 colors, defined by 2 colors, but it's also defined by, you have this reflectance, or this exponent rather, that defines how much that white, here let's do it this way so I can drive this value. Let's say exponent, I think I spelled that wrong. No, I didn't. So the default I think is 4, right? And as I crank this up, you see how the white is getting tighter and tighter. If I do a 2, it's there as a 8. So you can use this, just this alone, to do so many visual effects. And what's cool about this is it's camera based, camera vector based. So as you move around the sphere, it stays as it should, as it looks. What I like to do is, now what we do is we set this, so a lerp, let's look at a lerp real quick. A lerp is essentially just a linear interpolation, which is you have 2 values. So in our case, let's make this real simple. What do you get when you combine red and green? Do you guys know? Ooh, Aha. Hey, whoa. Oh, that's because these are the same name. See what was happening? I was trying to change the, yeah, so let's call this base. No, we'll call this Fresnel color. Fresnel color. All right. You're going to unplug here, or you're going to press the Windows key. Let's make the Fresnel red. All right, and now let's bring this back to a 4. 3. Why are you so bad? 1. Aha! So, what I've done is I've defined my A is going to be like the base. The B, which I said is my Fresnel color, which is being driven by the alpha, right, is going to be what wraps around it. And you can do this. Now I've set this up to where this is a parameter, this is a parameter, and so is this. And in the game, I can change this at runtime because they've been set to parameters. I like blue. That's nice. I'm going to plug this in, stop previewing. Now we should have a shiny blue with red outline thing, right? Pretty cool. Convert this to a parameter. Now what I haven't done here is done any texture work. And now a lot of materials that you guys will, what I'm doing is I'm creating a shader. This is a shade, I'm doing shader work from nothing. Most of the textures and materials that you see in game are using actual texture samples that are being plugged directly in. So this would be, for example, let's just go to one because I know they have one. I'm going to save this for a second. Let's say cube. Oh, sorry, grass. Yeah, there we go. So this is a more traditional material that's using texture samples. So what it's using is this grass image, as well as color and other certain properties to drive the overall effect. And this one's really cool because what it does is it actually creates like this really nice tiling effect and uses distance-based tiling. So although this is huge, whoa, wrong key. As you get further or closer away, it kind of changes. You see how we're further, and watch it change to like close grass right about here. You see that? And obviously it's not here. I can change this real quick. These should be, oof. Let's do this. 0.5. That was real low. 0.5. So I'm changing the tiling. Now it should be slightly smaller. Yeah, it's slightly smaller. But now what I've messed up is because I changed the tiling, I've changed the distance at which it fades. But that's more of a traditional material where you use textures and stuff. So now what we want to do, here's what we're going to do. We're going to hook up, and I probably don't have time to explain all of the inner workings of how it works, but I'm still going to do this because it's going to be fun. We're going to make this thing animate. So how do we do that? Well, how do we tell anything to do something along a certain set of time? Well, we need to get time. So that's actually something that you can pull into a material, is like get time. I wish it was that easy. Yeah, like I wish I had more time. Get time. Wonderful. What we're also going to do is we need to define a long time. How are we going to move this object? How are we going to make it do a thing? Well, the only way that can be done is through what we call the vertex shader. And what we're going to do is essentially just move the vertices a long time to a set value. So what we need is vertex, normal, world space. And what that is saying is essentially, if we're going to look at the wireframe of this sphere, it's going to choose the vertices on this sphere and push them out and then bring them back in along what I'm going to define as a cosine wave. So if you guys know what a cosine or a bell curve looks like, it's just whoop, so it'll go up and then back down to its value, and it'll keep doing that over and over again. So as a matter of fact, I'll show you guys. So if we were just to preview what time looks like against cosine, it will literally just be a blinking. That's all it is. And that value is what we're using to drive up and back, up and back. So we're going to take this, stop previewing, we're going to multiply it by I think this is the order, and then multiply this. All right, let's see. World position offset. Let's say 20. Yeah. So what I've done is I've taken those vertices, like I was saying, and along the cosine, I just multiplied them together, right? So it's like, hey, like for each vertice, do this thing. And now it's like, well, how much do you want me to do it? I want you to do it 20 units out, 50 units out, 100, right? 150. You can make it shrink even more. And so what you're seeing, this flickering, what's happening is it's going outside of its bounds. So every actor, every object, let's revert this, show, visualize. So these tools down here, the show stuff, this will toggle on and off stuff that already exists. So you usually typically don't want to touch this, but I know what I want to visualize. I want to visualize, where'd you go? Bounds, not bounds. Sorry, I'm having a hard. Advanced. Aha. So it's under advanced. Bounds. So see these little cubes? You have a blue cube that defines the shape, sort of the immediate extending box, and then the sphere that goes around it. That is your bounds for the actor. As soon as you scale an actor outside of that area, the renderer goes, it's not valid. I'm not going to render it. So it cuts it off. And that's what we're seeing with this cube. It's like, you're going right to the edge there, and like, I'm not sure if I should render it. So it's like, ugh. At 100, it's just fine. So what I'm going to do is the default is going to be 0. It's not going to move. We're going to make a little blueprint that makes it do that thing. Let's delete this cube because I know I want a cube. Sorry. Show bounds. You're gone. Don't need you anymore. All right. The next, and probably the, how do I put this? The most important part about UE4, the biggest thing, blueprints. It's basically how, if you're not a coder, you make things do the thing. And I love it because it made me realize that I like to program, but I just don't like writing code. So that's amazing that we have the ability to do that. BP, pulsing cube. Cool. All right, this is an empty blueprint actor. I will tell you a little bit about this because I definitely need to, and it's incredibly relevant. So, like I was saying with everything in Unreal, it's object-oriented programming. This is an empty actor. This is an actor blueprint. Parent class is actor. Every actor has a set of properties that comes with it, a class defaults, if you will. One of the main ones that comes with it is tick. Tick, though, is very dangerous for every actor. Not every actor needs tick. So that's something I would be aware of when you start. Avoid tick at all costs if you can. It makes sense to put it somewhere, and when you're testing and doing stuff, like plug it into tick. It doesn't matter. But once you get to like doing real game code execution, event tick is not reliable. So usually what you do is you create your own timer, and then you have that timer go out like 0.05 seconds, and it's just loops on that, and that works just fine too. But what we're going to do is something even more fun that I like over tick, which is timelines. And timelines are essentially, you're creating your own. Who has worked with like Premiere, Adobe Premiere, any video editing software? Yeah, so basically you're creating your own curves and allowing things to move along those curves at whatever rate you want. And the editing is similar to that. So let's see here. What we need first, though, is we need to add components for this blueprint to do a thing. So we know we want an overlap volume. We want the player to cross over this thing and it do a thing. So what we need is a collision, box collision. And we're going to go to the viewport and see that as soon as I add a box collision, it appears. And I'm just going to leave it as box. But what I am going to do is set it to be a little bit bigger. Maybe not that big. 150. 150. And 100. So, so you guys know, Unreal is measured in centimeters. So 1 centimeter is 1 Unreal unit, or 1 UU. So whenever you're working, try and work in centimeters, at least when you're doing external stuff. Unreal does a great job of offering conversions. Like, you can set your project to be in meters or kilometer or kilometers or whatever you want, but just know that now your world is in that measurement. And like, if you're importing something in centimeters and you're working in kilometers, that shit's going to be small. So yeah, just be aware of that. So cool, we have a box that the player is going to overlap. I want to be able to see this thing, so I'm going to uncheck hidden in game. So now when I drag this, I press the marketplace button. So now when I drag this blueprint into the world, we see that it has this cube there. And it's the center of my selection because it's the only component, and it's the root component. So now what I'm going to do is I'm going to put it right here for us to walk into. Let's go back here. Now we want to add a static mesh. This is going to be our cube, or let's even just, whoops, not an instant static mesh. And as you can see, this drop down, there's tons of different, these are component types, right? So there's vector fields and radial damage and like impulses and VR, like these are new, the stereo layer and VR notifications, those are new. You had to make those on your own. Lots of like interp movement, projectile movement. So lots of stuff here, and like, it's overwhelming at first, but once you know what you need to make, all the other stuff you kind of just ignore. So we want a static mesh. Let's do this, static mesh, cool. Where is it? Well, it doesn't exist. When you add it, there's no property here, so we need to make sure there's a mesh. So let's do cube, chamfered cube, awesome. Now, this cube exists in the world because I dragged the blueprint into the world. We are going to move it. So there's two things here. This is, I'm working in the blueprint editor. This is the parent blueprint. Whatever I do here is going to replicate here in the scene. However, if I have an instance of this thing placed in the scene and I start to manipulate it here and I update the parent blueprint, it's not going to change what I've done here. For example, I want to move this cube up to these steps here. I don't want to do it in this fucking thing because this is going to take forever. I'll be like, okay, is it here? Let's go back. Nope, wrong axis. Okay, like messed up already. So what I'm going to do is grab this sucker. You can double click it, and then I'm just going to move it. Now it's still going to be part of the blueprint and still doing its own thing, but in this instance of the blueprint, this cube is right there. All right, so now what we want to do is we want to add some logic here. We're going to delete this because this is all not necessary. On the box collider, there are events that can be made here. You have a bunch of these on component hit. So if something hits this box, it'll fire off and do a thing. We're looking for on component begin overlap, meaning once something overlaps this box wireframe, do a thing. So I'm going to add a timeline. Let's say pulse cube. Once we start, we're going to play. And the big thing that we haven't done yet is that we need to get this material. We need to make sure that this material on this cube, which we haven't done yet. So we want the pulse. This is why you name everything the same. Ooh, it didn't save. There we go. Haha. Now it should exist. Pulse and cube. Yes, this is why you name things. Cool. So now this cube has this cool like red, pink, cool thing on it. The Fresnel makes it so because the faces are flat, so it gives it this cool effect since it's not a sphere. All right. So now we've applied the material. What we haven't said though is that this material is dynamic. Like we don't know, this material doesn't know it's supposed to update. So what we need to do is tell it that this thing is dynamic first and foremost. So on begin play, we're going to grab this mesh, which has the material on it. And we can do, I'm going to try this, create dynamic material instance. Yeah, it's the same shit. And I'm going to rename this because that's what you do. This isn't called static mesh. This is called our cube mesh. And that is terrible. Mish. Yes. Yes. And it should be F2. Thank you. Overlap box. Cool. So on begin play, we're going to create a dynamic material and then apply it to the cube mesh. So really all this is doing, and you need to, it used to be that you had to do this for a lot of things. This workflow, like I was telling you guys, stay relevant. This workflow has already changed. We like to use what we call custom primitive data, which is every mesh has 32-bit float point that you can write to. It's called custom primitive data, and you can use those same values. So here, instead of element index, it's the primitive data index. So it can be 0 to a 32, and you can use that to tell the mesh to update a material instead of creating, because every time you create a dynamic material instance, the engine basically has to step through those and match it up and then be like, okay, now do the thing. With the primitive data, it doesn't have to do pretty much any of that. It's like, well, yeah, this is the primitive that you're telling to do the thing to. Just do the thing. But here we'll do the more traditional, and this still works just fine because it's managed and smaller. So now we want to do set material. Boom. So what we've done is we've created the material instance. Now that it's created, we're going to pull from that and set that as the new material for the cube mesh. This all happens as soon as I press play because it's on event begin play right here. Another big thing, if you're a coder or organizer, actually, let's do marquee select, press C, comment on begin play, create dynamic material. This shit is going to help you so much. One of my teammates, I think he came and did a talk for you guys, Evan, super organized, Mr. Organized. He and I go head to head with that. But he has found, and I didn't, the whole time I worked at Epic, I never saw anyone use them this way. But he literally creates them as comments to come back to, where he's like, edit this part, and then it's like in red, and then he'll make it real big or some shit, and then put it here. So that way when you're out in the graph, you're like, oh, like this is something to pay attention to, instead of it being a whole box. And he'll create lists doing that too, which is nice. And that's part of the organization stuff that I was telling you guys to kind of figure out what works best for you. Because he does that, and I've never seen anyone do it, and it works great. So yeah, pay attention to that stuff. And also, this one's fun. Don't get yourself distracted. The reroute node. Double click a line, and it allows you to add and I can do, yeah. This is a great way to piss off developers who are very particular about things. Evan and I go back and forth. We don't bother each other at all. We're just like, yeah, we like the way that looks, and then we'll like add a reroute node, and we're both like, yeah. All right, now what we need to do here. Where are you? So the one thing I did mess up, which is totally fine, is I didn't have the source material. So what it was doing is it was like create dynamic material and apply it to this mesh, but I didn't say what material to create from, so I had to set the source mesh or source material. Now we're good. Now this thing can be edited freely however we want. So go back to our timeline. We're gonna say once you overlap this box, play this timeline, which what does that mean? Well, we're going to drive a float value, which was our world position offset. I'm going to add a few points here. We're going to make a little bell curve. So click on this. So shift click to add points. Time, this is going to be at 1, right at the middle. Value of, well, let's do 1 if we're going to drive. It all depends. So this is where the tech art stuff comes into play. So what I could decide to do is drive the value of world position offset, this value here. I could drive this as 20 or 100, right? I could say in this timeline that I'm creating, go from 0 at the start to value of 100 and then back down to 0. And that could be fine. But if I want for this to be a multiplier, I could do that instead. So whereas I could have this be like the default value is like 20. And now what you can do is you can have that be a multiplier of the actual value instead. So you can kind of crunch, instead of working with big numbers, it helps you kind of bring that stuff down. But what we're going to do is, because I really love one-to-one, the default value is 0. We're just going to drive this value. It's not a big deal because we're only working with 1. So this is going to be value of 100. It's going to be scary, but here's the cool thing about this. You can zoom to fit these two buttons. This whole workflow has improved in UE5, by the way, because it's not super friendly. But you press these two and it fits the graph to what you're looking at. Then what I like to do is I scroll select, right click, auto, nice bell curve. I'll select this, make sure, see it's at 1.9, I want it at 2. The length of this thing is 2 seconds only. This guy is at 0. Holy God. What? We'll try that again. Let's, yeah, that's okay. Hey, that's okay. Value of 100. Oh, that's why. Haha. User. Yeah. Oh, yeah. 1. Beautiful. All right, we're good to go. So, yeah, here's our little curve. Now, let's name this. This needs a name. It's external curve. It says new track 0. I know what this should be called. This is going to be called world position offset. I just acronymed it for you. Abbreviated it, sorry. So now what we need to do is we do set, and this is a scalar parameter because it's 1. If it's a vector, we have multiple vectors. Scalar parameter value. Awesome, that's not the one we want. We want it from this material. So what we're gonna do, let's do this instead. Come here. All right, promote to variable if you're not gonna be nice. So now what we're gonna do, because I need to reference this I need to find or use this material, this dynamic material we've created. So I need to make it into a variable. So I'm just going to call it dynemat because I'm not trying to be creative at all. So what's happening now is it's going, hey, on begin play, this cube mesh that we have, create a dynamic material out of the material that we have, set it and call it dynamic mat, and then apply that material to the cube mesh. And now all we have to do is we go grab this dynamic material and do set scalar parameter value, plug that into update, and plug this world position offset into the value because that's what we're driving, right? Now the only thing I need to do is name this correctly. I think this is WPO. Let's make sure. Yep, it's called WPO. Now, when I overlap this, wait, make sure before I, cool. And now I'm thinking what we can do. Let's just have this play. Let's watch this happen in Magic. All right, so go, boom. Ooh, we really stretched it. So it's not looping either. So it's only played once, which is fine because I didn't tell it to loop. So loop, boom. Let's not do that large. Let's do like 50. Cool, not doing anything. And now it's gonna loop, and as you can see, it's not super smooth because my curve isn't like the start and end aren't actual nice curve, but it's doing a thing, right? And that's what we wanted. So basically, this is a form of, I've created a bit of visual effect. I wonder if now it'll do it. Auto. You should be flat. Flatten. Yeah. This is how you get the smooth. Enter and exit. We got 0. User. You're going to go even lower than that. Just because it's still pushing it. Yeah. So it's going in itself. That's why. Because it's going from basically 1 to 0 up to the value, and then from 0 back down to, so it's going in itself a little bit, which is fine. That's okay. But as you can see, it's doing stuff, right? And that's really what we wanted. And this is really the process of like, from it took me a while, just this, like manipulating a material based on a game event, right? It took me a while to understand that process. But once I did, I'll never forget that now. And I can do that in a ton of different ways. And I can make something do what I want, which is super empowering. And really, it really gives you the confidence to like keep moving forward once you do stuff like this. That's all I really have. I could easily talk about this shit all day. I could go for another hour and just talk about other stuff if we wanted. But I need to eat, and it's also almost 9.